Hello again with another example related to a motion in one dimension. In this example, we have the question saying, suppose a car merges into freeway traffic on a 200-meter long ramp. If its initial velocity is 10 meter per second when it's entering that merge in the free or on the highway, and it accelerates at 2 meter per second square. Now, how long does it take to travel the 200-meter up the ramp? Like, how long does it take? What's the time required for this car to complete the 200-meter distance? As you can see from the supported figure, we will assume that the initial position is 0. The initial velocity when we captured that car from that moment was 10 meter per second. The total distance is 200 meter, and we don't know how far uh, this car, how long this car will need to cover all this distance. Also, we can add to this example, or we think about it in different way. All right, if I want to solve this problem, I need to find out uh, what's the time. So you might be start with the idea of, all right, I have the v sorry, I have the v final equal the v initial plus the acceleration multiplied by the time. Well, when we look at this equation, you will find that, okay, we have two unknown in this situation. I don't know how much is the final velocity of this car at 200 meter, and I don't know how long does it take to finish the 200-meter acceleration and the initial velocity. We have them, so definitely we need another equation to help us finding one of these two unknowns. So when we look carefully, and I'd mentioned that in previous example or previous video, that if you look at information such as you have how far did you travel, what was the acceleration for the time you've been traveling, one of the two velocities like the initial or the final, and there is no need to look at the time, it's really good to use this equation. The final velocity square equal the initial velocity square plus 2 the acceleration multiply the distance. So we don't need to worry about the time for this travel. And when I look at it, well, I do have the initial velocity, so it's a 10 squared plus 2, and the acceleration here also is 2, and the total distance was 200 meter. All right, so when we do the math for this scenario, I will have here 100 plus 4, it's an 800, that will give me 900. However, I'm looking for the final, I'm looking for the final velocity, not the velocity squared. And that will mean if I put 900 under the square root, that will give me it's a speed of 30 meter per second. Great. So I know how much was the velocity of the car at the position of 200 meter from that starting point or when it was merging the road. Okay, good. So from here, I can go back to this equation and solve the time. So let's write it down. V final equal V initial plus the acceleration multiplied by the time. This is 30, this is 10 plus 2 and multiplied by t. Just simply rearrange the formula. It will be 30 minus 10 over 2, and that will give me 20 over 2. That will give me 10 seconds required for this car to travel that 200 meter ramp fully. Okay, now this is one of the ways to solve these problems, which the idea of this example that you not always gonna find problems where you just pick one equation of the kinematics equation and it will be solved. There is a chance for questions required that you will be using two equations to get the what is being asked from the question. Now, also this example can be solved in a different way completely if you can't figure out, all right, how do I deal with this, or which equation should I pick? It's the same example. So I'll start with, I'll erase all this, okay, and I'll show you the other way. It could be kind of like it's mathematically a way to solve this problem, more than it's like using purely the kinematics equation we have in physics. So again, I have the initial position, I know what's the initial velocity, and I know the acceleration, and I don't have the time. So I don't need to think about the final velocity. It didn't come to my mind. So this way I will be solving this problem. So it's an x equal x initial plus v t and plus half a t squared. Now we know this is the initial position and it will be 0. In this case, I have my equation like this. I know I will be covering 200 meters total. I know my initial velocity is 10 t plus half 2 t squared. When I look at this equation, it's 200 equal 10 t plus t squared. I can rearrange my equation and it will be t squared plus 10t minus 200. Okay, and that will equal 0. From here, I need to find a way to solve this quadratic equation. And we know in mathematics, to solve the quadratic equations, we can use that t, which is the unknown thing we need to find. We can follow this minus b plus minus b squared minus 4ac, and this one here under square root, and all divided on the 2a. To do that, and when you do that, replacing the values of the b, which is the 10, and the a will be the 1, the c will be the minus 200, and just doing that calculation, you will end with two values of the time. One of them will be positive, one of them will be negative. The negative one, normally with the time, it's not reasonable, because in other words, you're telling me this event happened even before we start the whole thing. Like if it comes maybe, let's say 20 seconds, minus a 20 seconds, that doesn't make sense. You're telling me this car merges to the freeway 20 seconds before it reached that point. So it's not acceptable. So you will find two values for the time following the quadratic equation solution, and one of them definitely will be the 10-second we found just with the first trial before. Okay, I hope you find this example useful and help you to think in different ways to solve problems. We'll see you again in another video. Thank you.